Welcome back, everyone. We're diving deep into the world of Eric Laithwaite today. You might know him from Maglev Trains.
Right, he's often called the father of Maglev.
But there's so much more to his story. I mean, we've got excerpts from a biography here focusing on his Maglev work. And let me tell you, this guy led a fascinating life.
Absolutely. He was a real pioneer, but also a bit controversial at times.
Yeah, that's what we're going to try to figure out. Was Laithwaite a genius ahead of his time, or did he stray a bit too far from accepted science?
Well, to really get Laithwaite, we need to go back to World War II. He was an RAF officer.
Oh, wow. So he saw action.
Well, not exactly front lines. He was a test engineer working on autopilot systems.
So like the early versions of what helps planes fly themselves today.
Exactly. Super high-tech stuff for that era.
It makes you wonder how that shaped his thinking later on.
I'd say it definitely had an impact. And then after the war, he went on to study electrical engineering, ended up at the University of Manchester, and get this, he worked on the Manchester Mark I.
The Manchester Mark I. Wait, isn't that one of the first computers, ever?
That's the one! He even got his master's degree for his work on it. Talk about being at the forefront of innovation.
Wow. So he's working on autopilots, then one of the very first computers. And that's all before he gets into Maglev.
Well, Maglev came a bit later. It was during his PhD research that he really got into linear induction motors.
Okay, now linear induction motors sounds a bit like, something out of Star Trek. What are they exactly?
Think of it like an invisible magnetic hand that can push objects along a track.
Okay, I can kind of picture that. So Laithwaite was basically fascinated by magnets.
He was. And he got really deep into figuring out how efficient these motors could be. He even came up with something called the goodness equation.
Goodness equation. Was he judging how moral the motors were?
No. It's a way to measure their efficiency. And back then, most engineers thought smaller motors were always more efficient. But Laithwaite's goodness equation showed that bigger motors could actually be more efficient.
So he was already challenging the assumptions of the engineering world.
Absolutely. And all of this research with linear induction motors led him to the work he's best known for, Maglev trains.
Yeah, Maglev. And this wasn't just theoretical for him, right? He actually built a working system.
Oh yeah, he called it the Magnetic River.
Then,
It was even featured in a movie.
wait, are you talking about The Sky Who Loved Me?
That's the one. Remember that scene? James Bond strapped to the table, and that levitating tray comes along, serving up a not-so-pleasant fate for the villain.
Oh, yeah, I remember that. So this magnetic river, it wasn't just a Hollywood gimmick.
Nope. It was a real demonstration of Laithwaite's vision for the future of transportation. He imagined super-fast trains gliding effortlessly above the tracks, no friction, reaching incredible speeds. He was truly the father of Maglev.
Wow, that's amazing. But didn't things take a kind of strange turn after that? With his work on gyroscopes?
Ah, yes, the gyroscopes. That's where things get a bit controversial.
Yeah, gyroscopes. Those spinning toys that seem to, defy gravity. What's so controversial about them?
Well, it all started with a famous lecture he gave at the Royal Institution back in 1974. Laithwaite went on stage and argued, pretty passionately, that the behavior of these spinning objects couldn't be fully explained by, well, the laws of physics as we know them.
Hold on, was he saying Newton got it wrong?
He even did a demonstration. Picture this. Laithwaite lifts this heavy, spinning gyroscope with one hand, seemingly effortlessly. But when it's not spinning, he can barely move it.
So how did other scientists react to that?
Let's just say they weren't exactly thrilled. Lots of physicists pushed back hard, arguing that gyroscopes do follow the laws of physics. They said Laithwaite's demonstration could be explained by well-established principles. It caused a huge stir.
I bet it did. So what happened? Did Laithwaite back down?
He eventually admitted that gyroscopes do operate within the known laws of physics. But he never completely gave up on this idea that they held secrets to a totally new form of propulsion, a way to create motion without traditional engines or fuel.
So even when facing pushback from, the entire scientific community, he still held on to this belief about gyroscopes.
He did. That's something that really defines Laithwaite, this unwavering belief in the unexplored potential of things. But gyroscopes weren't his only unconventional interest. He had some pretty wild ideas about moths, too.
Moths? Wait, how do moths fit into all this?
Well, Laithwaite was a man of many passions. He had a huge collection of butterflies and moths, actually one of the best in Britain. But he wasn't just collecting them. He had a theory, a rather unique theory, about how they communicated.
From defying gravity with gyroscopes to deciphering the language of moths? Sounds like Laithwaite's mind was always searching for the unexpected.
That's a great way to put it, and you won't believe this. He actually thought moths communicated using electromagnetic waves, like tiny little radio
Oh,
signals.
really? But scientists already knew about pheromones, right? Those chemical signals insects use.
They did. But Laithwaite thought the electromagnetic waves allowed moths to communicate over much greater distances, even when there wasn't any wind to carry their scent. It was like he was always looking for a different way of looking at things, even when it came to moths.
So he's pushing boundaries, challenging conventional thinking, no matter what he was studying.
Yeah.
And you should wonder what else he got into.
He really did, always thinking outside the box. But we haven't even touched on his last big project. Even in his later years, he never slowed down.
Oh, right. He had that idea for, what was it called? The Magnetic Launch Assist System?
Exactly. He was trying to revolutionize space travel.
Okay, now that sounds straight out of science fiction. What exactly was he envisioning?
Imagine a giant electromagnetic track, like miles long. The idea was to use powerful magnetic forces to launch spacecraft into orbit, giving them a huge initial boost.
Whoa, like a giant electromagnetic slingshot for spacecraft. That's pretty wild.
It is. And you know what? NASA was actually intrigued. They saw the potential for saving a ton of money on space launches and making the whole process more efficient.
So even in retirement, Laithwaite was still tackling these huge, ambitious projects.
He never stopped pushing the limits. Sadly, though, his work on the magnetic launch assist system was cut short. He passed away in 1997.
Oh, that's right. What a loss. But his ideas didn't die with him, did they?
Absolutely not. That magnetic launch assist system, it's still being developed today.
Wow, so his vision is still alive, helping to shape the future of space travel. That's incredible.
It really is. And it just goes to show you, even the most unconventional ideas, the ones that challenge the norm, can have a lasting impact. Laithwaite's willingness to explore the unknown, to push boundaries, is a legacy that continues to inspire innovation.
I mean, think about it. This is the guy who worked on autopilots during World War II, helped build one of the very first computers, pioneered maglev trains, then got fascinated by gyroscopes and moths.
He had such a wide range of interests, always curious, always wanting to learn more.
Yeah, and not just learn, but really understand how things work. And then you try to figure out, okay, how can we push this further? How can we use this knowledge to do something new, something incredible?
He wasn't afraid to challenge what we thought we knew, which is so important in science. I mean, remember those Royal Institution Christmas lectures he gave?
Oh, yeah. He gave two, right? One in 1966 and another in 1974. They were legendary.
They were. And Laithwaite had this amazing ability to explain even the most complicated scientific ideas in a way that was exciting, accessible, especially for young audiences.
Yeah, he made science fun. He had this knack for connecting with people, showing them the wonder in the laws that govern the universe.
It wasn't just lectures either. He wrote books, did TV appearances, even consulted on films. He really wanted to share his passion for science with the world.
He did. And that's something we can all learn from, No matter what we're passionate about, being able to communicate it effectively, share that knowledge with others, it can make a real difference.
I agree. So looking back at Eric Laithwaite's life and work, we see this incredibly bright, determined person, driven by an insatiable curiosity. He was a pioneer in Maglev Technology, a champion of thinking outside the box, and a gifted communicator who inspired generations with his love for science.
He really was. But let's go back to that question we started with. Was Eric Laithwaite a genius ahead of his time? Or was he a maverick who strayed too far from accepted scientific thought?
Maybe it's a bit of both. There's no doubt he was brilliant, but he also had this, this rebellious streak, a willingness to question conventional wisdom and explore ideas that others dismissed as, well, a bit out there.
Yeah, and it's that unique combination, brilliance and rebelliousness, that made him so fascinating, so influential. He pushed the boundaries of science and engineering, encouraged countless others to follow his lead and dream big.
His legacy reminds us of the power of curiosity, the importance of challenging assumptions, and the transformative potential of unconventional thinking. And as we wrap up this deep dive into the world of Eric Laithwaite, we're left with one question that still intrigues scientists and engineers today.
Was he ultimately right about gyroscopes?
Right. Could we actually harness those unique properties to create a whole new form of propulsion?
It's a question that may linger for years to come. It speaks to that enduring fascination we have with the mysteries of the universe.
Yeah.
And it reminds us of the legacy of this man who dared to explore them. It's almost like he left us with a challenge, to figure out if gyroscopes could really unlock a whole new era of transportation, or if they're just, well, really cool spinning things that follow the laws of physics. What do you think?
I think it definitely needs more exploration, more experiments. That's what's so great about Laithwaite's legacy, right? It wasn't just about him finding all the answers. It was about inspiring the rest of us to ask the right questions. Keep that curiosity alive, because that's what drives progress, isn't it?
Yeah, it is. He's like reminding us that science isn't about memorizing a bunch of facts from a textbook. It's about how we think, how we approach the world with that sense of wonder and, that willingness to push the boundaries of what we think is possible.
Exactly. And that desire for knowledge, for asking questions, we can all do that, no matter what we do or who we are.
So looking back at everything we've talked about, do you think Laithwaite was more of a visionary, someone who saw a future we haven't even grasped yet? Or was he just a brilliant mind who maybe went a little off track?
Maybe it's somewhere in between, right? He was full of these contradictions. A respected scientist who embraced these unconventional ideas. A gifted engineer who, at the same time, questioned the very laws of physics. And don't forget, this charismatic communicator who could make even the most complex stuff seem easy to understand.
Yeah, and those contradictions, that willingness to just dive into the unknown, that's what makes him so interesting, so influential.
Definitely. He left behind this legacy of questions, this challenge to keep exploring, to keep pushing the limits. Who knows, maybe someday someone will unlock those secrets of gyroscopes and show that Laithwaite's intuition was right all along.
It would be amazing.
Oh.
But until then, the mystery remains.
Yeah.
And I think that's part of what makes science so exciting. It's a constant journey of discovery, this quest for knowledge driven by curiosity, imagination, and, yeah, maybe even a little bit of daring.
I couldn't agree more.
So as we wrap up this deep dive into the world of Eric Laithwaite, we want to encourage you to keep exploring, to keep asking those questions, never stop challenging those limits. You never know what incredible things you might discover out there. Thanks for joining us, everyone.